Hello. Yes, we welcome you to PSSB with me, Richard here. We are looking at this question. It says, consider the circuit above. When the switch is open, the voltmeter reading is 13 volts. Okay. When the switch is closed, the voltmeter reading reduces to 12 volts. Okay. So when we close this one, that's the reading we get, 12 volts. Okay, the question says, state what is the cause of reduction in voltmeter reading when the switch is closed. So when you close the switch, what's the cause of decrease in the voltmeter reading? The cause is presence of internal resistance in the battery. Yeah, that is it. So when the battery has internal resistance, there's potential drop caused by current going through the battery. We have to remember that when the switch is open, there's no current going through the battery, so there is no potential drop. But once current passes through the battery and the battery has internal resistance, then there will be potential drop or decrease in the potential difference. Yeah. Then comes this question. It says, state what each of the following represent. Number 1, 13 volts. We have to remember that 13 volts is obtained when the switch is open. Opening of the switch means no current goes through the battery. And what does that mean? That means that the reading taken under that circumstance is EMF or electromotive force. It is the total possible energy which the battery can provide per unit joule, which is passing through the battery. So, 13 represents EMF or electromotive force. Okay, how about 12 volts? We need to remember that 12 volts was obtained when the switch is closed. Closing of the switch implies current going through the battery. So when current going through the battery, there's that potential drop due to the resistance of the battery. So what's that reading called? We call it terminal potential difference. Yeah. Then comes this question. It says, calculate the internal resistance of the battery. Okay. How do you go about that? We need to know that the relationship between EMF and the V terminal is this, which you can also round up as IR plus IR. But then, what do we know? We know EMF. We said it is 13 volts. And we know VT. we found it as 12 volts. Okay? We need current to proceed and we don't know. So what do? Let's use this space and say, calculating I. This I is IT. Okay? So for that case, what do? You say V is equal to IR. And we need to know that for the case of the circuit, when you are using Ohm's law, we use terminal voltage, which is now 12, giving you current times our resistance of 10. So implying that 12 is equal to 10I. So current is going to be given by what? 12 over 10, giving you 1.2 ampere. So having the current, now we can substitute. Remember, E is 13. I is 1.2 times the resistance, which is 10, plus I, which is 1.2 R. And we have 13 equals to 12 plus 1.2 R. Next step is to correct like terms. We are going to say 1.2 R is equal to 13 minus 12, which is equal to 1. So in other words, R is equal to 1 over 1.2, giving us this 0.83 ohm as our internal resistance. And with that, I would like to say thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Don't forget to subscribe, to like, to comment, to share. And we also need to remind you that PSSB handles Physical Sciences Grade 12, 11, and 10, and Natural Sciences Grade 8 and 9. Our advice to you is that when you're using the channel, don't go to video, go straight to playlist and select the material which belongs to your level. This channel has a very wide scope from grade 8 to grade 12. So sorting out the material would be a problem, but we have done that for you. If you are grade 8 and 9, just go to Natural Sciences Grade 8 or Natural Sciences Grade 9. If you are grade 11 and 10, just go to Physical Sciences Grade 10 or Physical Sciences Grade 11. For grade 12, every chapter is presented independently. So every chapter is a tile. Just go and click on the tile of the topic you want to see. With that, I would like to say we love you. Thank you very much. See you next time. Bye-bye.